Welcome to our channel. Today, we're diving into the mysteries of the cosmos with 10 fascinating facts about the universe that will blow your mind. Get ready for a wild ride through the vast expanse of space as we explore mind-boggling concepts, incredible phenomena, and the sheer awe-inspiring scale of it all. From the expanding universe to the possibility of life beyond Earth, we'll journey to the frontiers of human knowledge and ignite our curiosity about the cosmos. Let's get started. Imagine this, the very fabric of space and time stretching. That's right, the universe has been expanding since its explosive birth, the Big Bang, roughly 13.8 billion years ago. Now picture this, galaxies, those vast islands of stars, are moving away from each other. And here's the kicker, the farther away they are, the faster they're receding. It's like a cosmic dance where everything's moving apart. This expansion tells us a lot about the universe's history and future. It suggests a beginning, a point where everything was condensed into an incredibly hot, dense state. And as for the future, well, the expansion is still going strong, driven by a mysterious force we call dark energy. The expanding universe is a mind-boggling concept, but it's supported by a mountain of evidence. We'll dive deeper into some of that evidence later, but for now, let the vastness of it all sink in. The universe is a dynamic, ever-evolving place, and we're just beginning to grasp its true nature. Here's a humbling thought. What we see in the universe, stars, planets, galaxies, makes up a tiny fraction of what's actually out there. The vast majority of the universe, about 95%, is made up of something we can't see or directly detect: dark matter and dark energy. Talk about mysterious. Dark matter, as the name suggests, doesn't interact with light, making it invisible to our telescopes. But we know it's there because of its gravitational effects on visible matter. Think of it like this. Imagine a ghostly web holding galaxies together, providing the extra gravity needed to keep them from flying apart. That's dark matter at work. Now let's talk about dark energy, the even more enigmatic force that's accelerating the universe's expansion. It's like a cosmic anti-gravity pushing everything farther and farther apart. We don't fully understand dark matter or dark energy, but scientists are hot on their trail, trying to unravel their secrets. These mysterious entities hold the key to understanding the universe's ultimate fate. Black holes are among the most fascinating and extreme objects in the universe. Imagine a region of space where gravity is so intense that nothing, not even light, can escape its clutches. These cosmic monsters form when massive stars collapse at the end of their lives, creating a point of infinite density called a singularity. Think of it like this. Take all the matter in a star many times the mass of our sun and crush it down to a single point. That's the incredible density of a black hole singularity. Around the singularity is an event horizon, the point of no return. Once you cross the event horizon, there's no coming back. You'd be inevitably pulled towards the singularity, spaghettified by the intense gravity. Black holes come in different sizes, from stellar mass black holes, a few times the mass of our sun, to supermassive black holes, millions or even billions of times the mass of the sun. These cosmic behemoths lurk at the centers of galaxies, including our own Milky Way, shaping the evolution of galaxies and the universe itself. When massive stars explode in spectacular supernovae, they can leave behind incredibly dense remnants called neutron stars. Imagine a sphere only about 12 miles across, but packing more mass than our sun. That's the mind-boggling density of a neutron star. To put it into perspective, a sugar cube-sized amount of neutron star material would weigh billions of tons. That's about the same as Mount Everest. Neutron stars are like giant atomic nuclei, made almost entirely of neutrons packed tightly together. They spin rapidly, some making hundreds of revolutions per second, emitting beams of radiation from their poles. These beams sweep across space like cosmic lighthouses, and if Earth happens to be in the path of the beam, we detect them as pulsars. Neutron stars are extreme laboratories for studying the fundamental laws of physics under extreme conditions, offering insights into the nature of matter and gravity. When we gaze up at the night sky, we're looking back in time. Light from distant stars and galaxies takes time to reach us, so we see these objects as they were in the past. The farthest we can see is determined by the age of the universe, about 13.8 billion years. This defines our observable universe, a sphere with a radius of about 46.5 billion light-years in every direction. But here's the catch. The observable universe is just a tiny fraction of the entire universe. The universe is likely much, much larger, possibly even infinite. Imagine standing on a ship in the middle of the ocean. You can only see a certain distance to the horizon, but you know the ocean extends far beyond what you can see. That's our situation with the observable universe. It's a glimpse into the vast unknown, a cosmic horizon beyond which we can only speculate. If we could turn back the clock and witness the universe's birth, we'd see a blinding flash of light and an explosion of energy unlike anything we can imagine. While we can't travel back in time, we can still detect the faint afterglow of the Big Bang, known as the cosmic microwave background radiation. This radiation, discovered in 1964, fills the entire universe and has a nearly uniform temperature, about 2.7 Kelvin, just a few degrees above absolute zero. Think of it like this. Imagine the heat left over from a bonfire long after the flames have died down. The cosmic microwave background is like the faint warmth of the Big Bang, still lingering in the universe billions of years later. This radiation provides strong evidence for the Big Bang theory and offers clues about the early universe's conditions, such as its temperature, density, and composition. Hold on to your hats because this next concept will really stretch your imagination. Some theories suggest that our universe, vast as it is, may not be the only one. Instead, we might be part of a much grander structure called the multiverse, a collection of countless universes, each with its own unique properties and laws of physics. Imagine a cosmic bubble bath, where each bubble represents a different universe, some expanding, some collapsing, some with different fundamental constants. The multiverse is a mind-boggling concept, but it arises from some of our most successful theories in physics, such as string theory and inflation. While we don't have direct evidence for the multiverse yet, it remains a tantalizing possibility, suggesting that our reality might be far stranger and more complex than we ever imagined. Get ready to bend your mind because we're about to talk about time dilation, one of the most bizarre consequences of Einstein's theory of relativity. According to Einstein, time is not absolute but relative to the observer's motion and the strength of the gravitational field therein. Imagine two identical clocks, one on Earth and one in orbit around a black hole. Time will tick slower for the clock near the black hole due to the stronger gravitational field. This means time can pass differently depending on where you are in the universe. It's not just a theory. Time dilation has been experimentally verified with atomic clocks flown on airplanes and satellites. Time dilation has profound implications for our understanding of the universe, affecting everything from the lifespan of stars to the nature of black holes. Galaxies are not static islands in space. They're constantly moving and interacting with each other through gravity. In fact, galactic collisions are quite common, and when galaxies collide, it's not a simple fender bender. It's a cosmic dance that can last for billions of years. Imagine two spiral galaxies, each with billions of stars, slowly approaching each other. Their gravitational forces distort their shapes, pulling out long streams of stars and gas. As they get closer, the galaxies pass through each other, their stars and gas clouds interacting, triggering bursts of star formation. Eventually, the two galaxies merge into a single, larger galaxy, often an elliptical galaxy. Our own Milky Way galaxy is on a collision course with the Andromeda galaxy, expected to happen in about 4.5 billion years. Don't worry though, galactic collisions are slow and drawn-out processes. While individual stars might collide, the chances of our solar system being directly affected are slim. The universe is vast and filled with billions of galaxies, each containing billions of stars. With so many stars, it's hard to imagine that Earth is the only place in the universe where life exists. While we haven't found definitive evidence of extraterrestrial life yet, the sheer number of stars and planets suggests that the ingredients for life might be common throughout the universe. Scientists are particularly interested in planets located in the habitable zones of their stars, where temperatures are just right for liquid water to exist on the surface, a key ingredient for life as we know it. Missions like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, have discovered thousands of exoplanets, some of which are Earth-sized and located in the habitable zones of their stars. The search for life beyond Earth is one of the most exciting and profound endeavors in science. If we were to find evidence of even microbial life elsewhere in the universe, it would revolutionize our understanding of our place in the cosmos. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more amazing content about the universe. From the mind-bending concepts of dark matter and black holes to the possibility of life beyond Earth, there's always something new and exciting to discover about the cosmos. Keep exploring, stay curious, and never stop asking questions about the universe around us. See you next time.